All right, I guess we're on. All right, so for the record, thank you for joining.
Thanks for having me. It's a pleasure to be here.
Um, yeah, so I want to talk about object-oriented programming and specifically about this blog post I made. And whatever there is some discussion and I posted somewhere online, like a link to it, I get a lot of feedback that it's been very useful. Like either people in the comments or sometimes I will get a mail about it. And personally, I think in a way I kind of figure out object-oriented programming as as uh, as arrogant as it sounds, right? Um, and before we maybe dive into the idea itself here, just to give like a background. So I started programming pretty early. I started with a basic on my Commodore 64. So there, in this basic, there was not even concept of procedures, right? So it was like just go to certain line. So it wasn't even a structured programming or procedural programming because there was no procedures. Then later I learned um, Turbo Pascal. Then I started working with more of assembler, C, C++. Then I learned object object-oriented programming, kind of Java style. All right. I went through in my teenage years, I went through a whole long period, like a lot of developers go through my object-oriented phase, right? I've wrote bunch of like personal hobby software, especially kind of games, roguelikes, kind of things. And there were these types of games when you would have like a monster. Monster is an instance of inherits an actor or something, and there would be weapons. I guess you can kind of imagine how a game like that would look like. And every time I was doing anything with this OOP, it went terribly. Like it was after a month of working in my spare time on like a software like that, I hated it. It was just nightmare. And that was my point when I got kind of disillusioned with OOP. I started working professionally more often with C, so I was back to procedural programming, right? Um, and then I put the OOP kind of on the shelf. Then I started working more in enterprise, sometimes with Java, JavaScript. Again, OOP was visible because the software was not like written by me. I would have to work with it. And at that point, I started seriously thinking about the OOP, like philosophically, like what's going on with it? Why the appeal? Why people try to do it? Why does it always go wrong? I was reading and watching a lot of content over the years where people were sharing their own opinions. And after many years, kind of I've noticed that in the software I'm happy with, there are certain elements that are OOP and they function very well, but there is a bunch of stuff that isn't OOP. Right? So it wasn't like people want to do software just this way or just that way. And it was clear that there is a nuance here. There is a rule to this madness, so to say. And yeah, and I think that kind of gets to you see the data versus code. And in my opinion, this is the uh, what it comes down to. Yeah. So how does it sound? Any questions? Any thoughts?
I'm curious to hear what you have to say about the enlightenment you've discovered. Also, I don't want you to have to dox yourself, but would you be willing to share kind of you laid out the sequence of events that this unfolded within your career? Would you be willing to share rough timelines? Like, was this like the craze of the 2000s with enterprise Java that you started to experiment with OOP, or was it a different time frame?
Yeah, well, let me think. So I was born in the 80s. I started programming in the 90s when I was like, I don't know, 7, 8 year old. By the time I was 10, I must have been dabbing with Turbo Pascal, a little bit later with C++, C. I think the kind of OOP must have started, yeah, when I was a teenager. So it's like roughly 2000, right? And I think this is where Java started getting popular. I think a little bit later Ruby on Rails started being thing. A little bit later, JavaScript and web took over everything. So my personal OOP story would be like the 2000, a little bit before and a little bit after, and then I started more commonly working with existing software, and sometimes it would be like OOP, Java, or whatever. Yeah,
Gotcha.
it's been kind of years. Uh, yeah, and I think the enlightenment was not like a sudden realization, but just naturally over time. Uh, mm, I think the oftentimes the problem is like developers read something and they want to apply it because they want to apply it, and oftentimes it's not the right time to apply it, or they don't have the nuance when to apply it. And I think over time I just knew what works kind of intuitively, and I didn't think too much about it. And then when I started writing like blog posts, sharing my thoughts about OOP, yeah, I kind of had uh, an idea when in my own code something looks like OOP and works well, and when I usually see somebody else's code and I see that it's going wrong already, and I could kind of figure out why is that the case. Yeah.
Gotcha. And don't want to go on too much of a tangent, but and you could feel free to punt on this. But I'm also curious. We've had previous conversations about functional programming and your journey in FP. I'd be curious what the sequence of events looks like compared to when you started dabbling in that space.
Relatively, I don't think I used functional programming as in implementing something in Haskell, right? To me, I guess using Nix a lot is kind of a Nix is functional, uh, yeah,
Hmm.
effect free. So that's like a pure functional programming. But the principles of functional programming, they're kind of always there. Like the idea that instead of mutating something, it's better to construct a new copy and avoid managing state. It's kind of a common realization.
Hmm.
It's a little obvious that things go wrong where you have to manage rich state and consider all the possibilities, and trying to make as much as your code as you can without kind of getting into too much trouble was always kind of a good practice. I don't remember the time. I mean, I must have been like when I was writing code in Basic or something, or Turbo Pascal, there was not a lot of facilities for functional. Like those languages just did not work this way. Like they wouldn't have a good support for expressions and stuff like that, or even first class functions.
Hmm.
So yeah, but yeah, generally I have some thoughts about functional programming, but I am not like a lot of time I see discussion on social media and people talk like OOP versus functional programming, like one is an alternative to the other. which is kind of not the case. Like, just especially that, in my opinion at least, object-oriented programming is just a crappy metaphor. That's from all the reading and kind of listening to people talking about history of OOP. This is my conclusion, that at certain point, maybe in the 60s, people were toying with this idea that it's easier for humans to interact with computers if they can think about them in terms of like physical objects. That's kind of the I watched even some videos where people were in the 60s or 70s were showing demos of stuff to non-programmers where they would manipulate things as like kind of avatars of physical things. And I think the message passing between objects and encapsulation is just a kind of trying to adapt programming to common senses of a human being, right? But in a way, since it's a bad metaphor, everybody interprets it in different ways, and usually it goes off the rails pretty quickly. And you can say you're doing OOP, doing completely different things. Like the small talk was OOP, and Java will say, like, people will say Java is OOP, and they kind of do completely different things in the name of the same principle, which just tells you that the someone has to be confused here, and I think everybody is confused because the whole metaphor is completely wrong, because software is nothing like physical objects. Yeah, so that's kind of my thoughts on that.
Gotcha.
Yes, I think the title kind of already explains it, that in my opinion, what it comes down to is that OOP, especially educational, introductory content, books, they just confuse people. Because usually when you read you must have went through books about object-oriented programming yourself, right?
So sure, yeah. One of the first programmers I hung out with that was trying to get me into coding, the first book he hands is a book on how to do OOP in Java, which probably might not be the first thing you'd want to play with, but I bet that's a pretty common path for a lot of folks.
Yeah, yeah. And I don't know, in those books, would the examples be something like an animal, a dog, a cat, a dog barks and the cat meows, or something
Yep.
like a vehicle and the car and the truck and the boat, right?
Mm-hmm, definitely. You get right into the taxonomy.
Yeah, and this is completely wrong. Like at the basic example, and I'm not sure if it's because the people that try to teach it are completely confused, or is it just they don't see that their example are completely confused? Because in real software, you never have a dog. You should never have a vehicle. You should never have a car. And since I was as confused as everyone usually is when I was writing this object-oriented games, I would have a player, a monster, right? A sword as like an object. But that's completely confused, because the objects are supposed to decompose your software and not the data in your software or the data that your software uses. Does this kind of give you any hint already what I'm what I'm talking about. Because yeah, I think it requires a little bit of going over.
Yeah, it still is worth going over for the rest of the audience, but yeah, definitely a good hint.
Um, when I think about any kind of, in general, a software is bunch of code that takes input and produces output. Um, and in the software, there is a pretty clear. It's very rarely that it's hard to tell where something lays. It does happen. Distinction, but there's a clear distinction between what your software is made of and what passes through your software. So, and in the blog post, I used an example of exactly cats and dogs. That if, what kind of software could have cats and dogs? Let's say an application for veterinary shop, right? Uh, there will be like owners of pets that you want to store, and then we some pets with their medical history and with their billing, etc. But all of this is data. This is the data that passes through in and out of your software. Like when someone registers a dog, right? This is all data, and for data, it makes absolutely no sense to use OOP. The data should be represented in as plain as possible, data-oriented way. As in, like a dog should be a dog record kind of in a database.
Sure, I think that
And
makes a lot of sense.
and when things go wrong is where people try to apply OOP on that. They try to model the behavior of the reality or taxonomy of the reality with object-oriented principles on what is supposed to be the data in their software. The contrast to it would be something like email notification sender, right? That already sounds very OOP. It's you can have your application needs to send notifications to pet owners about the upcoming appointment. And then it's pretty clear to tell, okay, so there's an interface that has a method send a notification, right? You give it some arguments about the notification, and it's like a abstract interface. There can be a class that implements it by sending an email. And that's kind of OOP. And when you do OOP there, it works. It works just fine. Because your application is made of an email notification sender. It's not a data that passes through your system, but a component that implements the behavior of your system. Yeah, and then even if you start using, inheritance or some other stuff that like people like to complain about OOP, it might be good or bad idea, but usually it's not too terrible. When things go wrong is when people start making a pet an object instead of just a public bunch of fields, just a record in a kind of database like. And yeah, and it's kind of, that's all there is to it. The distinction between data and code, or like a component of the system itself, is kind of obvious. It's just people don't pay attention to it. At least that's my kind of experience. Yeah, in my blog post, I linked another blog post with someone writing kind of in a very similar terms. So I guess, yeah, I'm not the only person that sees it this way. Yeah,
Gotcha. Would you be okay if I ask you some questions about a
that's
code base
that's the
that?
whole point. It's supposed to
Cool.
be a discussion. You can push back. Yeah,
No,
I'm
everything you're
I'm
saying,
open
no,
for.
sweet. Yeah, everything you're saying, I agree with. And the introduction of how you're saying, you're essentially just having some piece of data. Your program is then transforming that data through a series of operations. When you say things like that, I start to hear FP, but I could see how pretty much anybody would model their framework they're used to programming in towards
Yeah,
that type of statement.
people will have preferences how to transform the data. Um, but you sometimes like, let's say you have a, a veterinary shop application, right? It's kind of easy to imagine that might be like a little system with a website where someone can log in, with a kind of a management interface for someone working in a reception, kind of a data entry and retrieval, and it all sits in a database. Typically you're going to put it in some data, and then all the informations that would go into the database, they're not code, they're data. Um, yeah, and then if you want to have the system kind of mutate this data, whatever someone fixes the typo in the name of an owner or something, or it changes the address, or credit card number, right? And then there will be an update, and then you have a mutable state in your database. But if you want to go functional way, you could structure the system as like a event-based system, or whatever. It's kind of how exactly to do the details. There is a lot about requirements and um, scale of this project and other personal preferences. So yeah, the discussion about kind of OOP, yeah, is orthogonal to that.
Gotcha. So hopefully this doesn't dox you too much. You're using your real name here, so it won't be any mystery that you're currently working on a code base called Fediment. And I'd be curious what your thoughts are for any aspects of that code base using OOP versus any other paradigms. And if you could give like an example, that might be pretty helpful for the listeners.
So since Pediment is in Rust, I think it's kind of naturally steers people into using data centric approach, even though like if someone is really set on it, they can try to do OOP, but usually they come back crying. Uh, but um, we do have this division as well. Like when you most of the what passes through Fedimint is just structs with public records. But for example, a concept of a module is behind an interface and works very much like a code component, and it's encapsulated, and we have reasons to encapsulate it, and it gives us a really nice architecture. So I don't know if anyone thought about it much, but somewhat naturally we do apply all the principles here in that code base, I think.
Gotcha.
Yeah. I might add kind of like in to contrast, when I was writing this object-oriented style games, right? And I would have you have like a player, and the player looks up the monster, and you call monster is being attacked, right? And you pass, I don't know, it passes a weapon interface as an argument, right? And then really quickly everything becomes very tangled with each other, and it's unclear to tell where certain behaviors are supposed to happen? Do you like subtract the damage from HP on this object or on that object? All right. If you contrast this with applying this principle, then the data about the game are stored um, as just plain public data, and then making a damage is just having a little function that does whatever logic needs to be done and subtracts it from where it needs to be subtracted and add X points where it needs to be added, and everything is pretty simple. And I would say the way usually games are written with like entity component systems, etc., is exactly that principle that the data is represented in as plain form as possible, and everything else, and you can still use like not inheritance, but you can still use objects for logical things. So even like subsystems or whatever, they would be more kind of object oriented, but they would have data passing in and out of them as data. Yeah.
Yeah, I think that makes a lot of sense. That's immediately where my mind also goes for refactoring kind of a goofy looking code base where you have monsters with a bunch of stuff in memory describing the current attributes of the monster, but how are you going to persist that? And then it just sort of naturally
Exactly, right. Yeah, like persistence become a problem. And I don't know if it's just my experience, or it's kind of hard to tell what exactly is happening in the heads of everybody out there. But when I look at certain Twitter posts where people argue about object-oriented programming, I never see this nuance here, which is not like some super great idea, but I am under impression that people don't see that. And because of that, you will get people talking over each other, and some people will be huge proponents of object-oriented programming, and they will swear their life how their software is always OOP and works great. And some people will, say that every OOP project they've seen is garbage, and they do procedural programming. And
weird.
each side kind of talks over each other, and they cannot find common ground. And then I look at my software, and it's really largely it's like a blend of OOP and procedural programming with data-oriented architecture. That's usually what the software kind of I have any say in designing ends up looking. That's components that make sense to abstract away behind kind of an interface. They're abstracted away and nicely decomposed, and then you encapsulate their state so you don't have to worry about it. But then data usually will be stored as plainly as possible. And yeah, everything will try to be as functional as makes sense, like as functional programming, like as makes sense. And it's like a happy family, like the data-oriented, object-oriented, functional programming, everything kind of blends nicely, and no one complains. Like in our project, I don't hear many voices like complaining about the general kind of kind of code style.
Yeah, I think
We have plenty of kind of issues. Like every software project, there's always something to improve. There are bugs, but I don't think people like write rants about how terrible the kind of code architecture is, or like they cannot complete something because they're in like a OOP spaghetti or anything like that. And I've been in projects like that where people constantly would complain how terrible it is, and we still have to kind of get it to work. All right. So
Sure. Yeah, it's pretty weird to hop into like a Python code base where you can tell somebody was trying to just be as OOP as possible. They're sort of fighting the natural flow of the language, a bunch of abstract classes just to do a very simple
Yeah,
program. It's a very awkward structure. I don't see any of that inside of Fediment. Some of the complaints are more of the complexity of problems that are trying to be tackled as opposed to like the approach for whatever paradigm to use to tackle those problems.
exactly. Like we do have complex problems and sometimes non-trivial kind of architectures around them. And oftentimes where our architecture gets a little bit weird is exactly the parts that are OOP like. Though we do have a reason why, like our kind of the object-oriented module system, where the module is behind the interface, and like we want to separate the module author from the core system, so we put this interface barrier between them, and there's a lot of complexity there, like on the kind of code level architecture, maybe not a lot, but there is a complexity there that isn't anywhere else. I actually have a blog post talking exactly about that problem. But I don't think we're going to be getting, maybe on some other call, some other time we can go over that
Sure.
that
Yeah,
blog post.
that's a fun
But
one to dive into.
we have a reasons to do it this way. Basically, uh, a pluggable module architecture that needs to enforce exactly the encapsulation. The all like one of the core tenets of OOP is encapsulation, and for the module system, it makes sense to separate the module and the core system with some kind of a wall interface. And then any non-trivial interactions between those two become kind of OOP architecture tasks. And we try to keep it as simple as possible, but it's immediately visible there. And if we ever go through this other blog post, I can every problem there I can point example in our code base.
Yeah,
So
I think that'd be
yeah,
a fun conversation for another time. But yeah, definitely there's a floor in terms of complexity with that problem since you have to have multiple distributed servers reaching consensus on what certain inputs and outputs are.
also
And
that's a different complexity. The in Fedimint code base, for example, the state machines, they're created by the module, but their life cycle is managed by the core system, and their progress is being pulled by the core system, but they require to be run with the context of a module. So we have a bunch of thingies pointing at each other to facilitate it. And yeah, and it's not non-obvious. It's not as obvious as most other code base there.
gotcha. Yeah.
So yeah, and the consensus is like the fact that we have to deal with distributed consensus, cryptography, other stuff is the essential complexity. It's not just because how we structure our code, but because
Mhm.
the task is complex. Yeah.
Yeah. And it is the OOP nature of how state machines are monitored and driven to a final state. It's actually quite nice once you get your head around it. You don't have to do too much as a programmer to interact with it, but to first understand it, there is certainly like a bunch of complexity that's hidden somewhere else. That's quite nice and lends itself to an OOP design there.
Yeah. Yeah. I mean, yeah, there's nice parts of it, uh, and there's the complexity you pay for it. But at the core, we have to do it because we do want encapsulation between components. And if we didn't want that, then I would prefer to have it plain data style, where every state machine would just be plain data with an ID. and somehow kind of everything would see everything else in a way. Like
Yeah,
this
so
this
as you
machines.
kind of, and this might be a little too in the weeds for the context of this call, but would that sort of just keep expanding on the event log that you've been working on? So anybody who's interested just subscribes to this event log, and that's essentially your state machine?
Oh, not sure. It's
Okay,
it's getting so nuanced and into the weeds, and it's yeah.
cool.
Yeah,
We can
plus for
pause there.
general public, this is gonna be too irrelevant, the exact details of yeah of our event log.
Yeah,
Uh,
I think that's a
right.
good pause on that tangent.
Yeah, I think that's kind of it. That's all I wanted to. That's all I wanted to say. All I wanted to explain to you, just so you can tell me if I'm going, if it makes sense or I'm going nuts.
No, that
Um,
made a ton of sense. I
yeah.
need to read your blog post now. And also, I'm curious who this Ted Kaminsky guy is because he's got an unfortunate name for how similar it sounds to Ted Kaczynski.
Yes, that's actually Polish last name as
Yeah,
well. Yeah, so that is
SKIs.
why. Yeah, I don't really follow his blog post regularly. I was just I've read a lot of stuff, all sorts of opinions and ideas about kind of object-oriented programming, all those like flame wars, people linking to all sorts of things. On my blog, there's a lot of past blog posts about OOP, linking to a lot of these materials, and yeah. So I must have found this somewhere, and it's very close to I was thinking at the time. Uh, yeah, and it made me inspired me to just write it down uh, as a one thing.
Gotcha.
Uh,
And I may be misremembering, but I think it's Uncle Bob Martin. I think that's the clean code guy. I can't recall off the top.
yes, Uncle
Okay,
Bob. Yeah.
Uncle Bob. He wrote a book on Elixir that I read many years ago at this point, and it was sort of his journey from going from OOP thinking towards more of an FP style. And essentially, his summary was very similar to what you gave of like at the end of the day, like what we're doing with these programs is we have some piece of data as an input, and we want to do something with that and then spit out an output. And it lends itself quite cleanly to an FP kind of mindset, but it doesn't have to be quite that rigid of a boundary. But it sounds like a very similar argument to what you just made in terms of how you would naturally structure your program. And that makes a lot more sense to just be transforming data to do something that you want, as opposed to just having these goofy code objects that are having stuff in memory that isn't particularly useful.
Yeah, yeah. The data can usually be just plain, and then a lot of kind of OOP critique or defense or miscommunication. Whatever I see, it can be explained by this conflation, like the lack of distinction between those two realms. And like recently, I've seen a Twitter post where someone was showing like a struct with a private field and saying like, what are we protecting this data from? Who are we protecting this data from? Right, from ourselves. Uh, and in the context of this, if it's data, then it doesn't make sense to protect it probably. But if it's a component, then you probably do want to shove its internal state behind an interface just so you don't have to worry about it. Like you don't even have to see it. It's not even about being paranoid, but more like you eliminate something from your context, so you have more spare mental capacity to worry about what you're actually doing,
Yeah,
right?
I think
Uh,
that makes a lot of sense to a simple API design where at a glance you know kind of what the behavior of this program is going to do. Then you can look into how the sausage is made. But yeah, that makes a lot of sense to not make that a public API. Then,
yeah, like in a concept of, let's say, email notification sender, Like what is exactly the user and password to the SMTP server that's going to be used is not very relevant from the rest of the system, right? And that is why it makes sense to shove it behind the interface and make the whole thing pluggable. And you can have all sorts of other notification, and the rest of the code doesn't care. It makes a lot of sense, and it's very OOP like. But when you think about like data that goes to your system, then it's usually so core that every other part of the system wants to have a visibility to all of it,
Mm-hmm.
or even if not all, to just like a small copy of it or something, or a reference uh, that makes sense for that particular task. But there is no point in trying to protect this data because it gets twisted, changed, and copied so many times that it's virtually pointless. And any sort of a more complicated interaction on the data becomes a exercise in designing weird interfaces trying to facilitate the transformation.
Mm-hmm.
It doesn't make any sense. Yeah. All right. I think we're going like what, 40 minutes or 50 minutes? I think we can wrap up for the start.
Yeah, I think this
Any
was
any final questions or something you
no
want
final
to add?
questions, but it's a great talking point. Thanks for taking the time to write the blog post and discuss it.
Thank you for joining me. Thank you
Yeah,
for
thanks for having
letting
me.
me make this happen. Yeah. Thanks a lot, and bye bye.
Bye.